All right. So again, medium, harder solving trig equations. What you're going to see here is that we're going to have sines and cosines and tangents and secants and cosecants all mixed together. Okay. There are some tips I can give you to solve these. You already know most of them from verifying the identities. So you should have a pretty good foundation. Let's see. Let's solve that one. What does it equal? 0. Good. And the sum of this one is solve for principal values of x. So going back to our trig identity or verifying trig expressions or equations, identities. That's what it is. Thank you. There were 4 tips kind of I gave you. Do you remember what those are? So what were those tips? Okay, so yep. So we changed it to sine and cosine. That was number 1. That's probably not going to apply to this one, yeah? What else was there? Just try to get your brains rolling on it. Oh, fraction math, yeah? Or do we have any fractions that we have to mess with yet? No. Okay. Oh, welcome to school. Factoring. Yes, that's a good one. Or FOIL. Okay. So, does that apply here?
Yes.
It does, actually. See how there's 2 terms? The cosine's in both terms, right? So the best way to solve this one is to factor. Oh, that's, stop it. Okay. We're on a roll already. And remember, you can always kind of turn these into an algebra equation if you want. This one might look like this. No, that's not what it would look like. X squared. Okay, and again, you see there x is in both terms. You can factor, right? So just to give you an idea of your previous knowledge. So what do I do past this point?
Wait, so is that cosine x in front of the sine x minus 1/2?
Mm-hmm.
Is that cosine squared x?
No, because you're taking a cosine x out of each term. Like here, I would take an x out, correct? And it would be x out front. It's the same idea. Okay. So do you remember algebraically what you do if you have something like this? Funny, but no. Does this ring a bell? Yeah. Okay, so that's what we need to do. So this would be any 2 items one of these has to be 0 for them to multiply to 0, right? So that's the same thing we're going to do here. Okay, so we got sine x or cosine x equals 0, and sine x minus 1/2 equals 0. So there are actually two answers, maybe more. Okay, so where's cosine 0? Where? 90. Are there any other principal values between 0 and 180? No. Okay. In radians, does anybody know that in radians? 5/2. Okay. So get practice right in those both ways. Where is sine x 1/2? Between negative 90 and 90. Those are principal values. Yep. Which is 5/6. Okay, so you actually have two answers here that satisfy that equation. Yep, that's what I say. All right. So factoring and foiling is one of those methods you can use. What was the fourth one? I don't remember it off the top of my head. Things aren't quite working well up here today. Anybody? Well, thank you. We're going to substitute. Substitute identities. Okay. Good, good. Nope. Are we good here? Okay, good. We're going to move on anyways. Okay. Solve cosine squared minus cosine plus 1. Equals sine squared x, I believe. Yep. Is there a stem on that? Okay, 4, 0 to 2 pi. So this is where you're going to see the answer in radians because they've specified. All right, so you'll want to write your answer in radians on this one. I just say write it in both. It gets you practiced up that way. Okay. I think that might be a plus. Yep, make that a plus. It makes it a much more friendly one. Okay, any ideas? You might want to, you might be able to do that, but there's a 1 here. So that's a good idea. Where are you headed with that? Yeah, so there, you're seeing some different ways to go about this. You're thinking. So let's just start here. And so if we had cosine squared x minus cosine x equals sine squared x minus 1. I don't know if that got us anywhere. Is that an identity yet? Yes or no? Careful. Cosine squared is 1 minus sine squared. That they don't. But you can still put 1 minus, or sorry, you can still put, we also know that sine squared is 1 minus cosine squared. Okay, so we can put that in for this, and the ones are going to cancel out, right? Uh, 1 minus cosine squared x minus 1. So these actually go bye-bye, right? Thankfully. So good use of substituting the identity in there. Now we're all in cosines. That's kind of nice, right? What can I do with that? Add? Somebody said it? Yeah, we can add cosine squared over here. So they'll like terms. So we have 2 cosine squareds minus a cosine, and that is 0. Yeah, you can factor. And we're left with 2 cosine x minus 1. Yeah. And set them equal to 0 and solve. Okay. So why don't you go ahead and do that on your own, because it's good practice. So set them equal to 0, each of them, and solve, so you get 2 answers. Or maybe 4, actually. We'll see. It's 0 to 2 pi, so make sure you're in radians there. Do anybody need help? Are we doing okay? Up here, you see how I set them each equal to 0? It's the same idea. So 2 here. Yep. Elizabeth, your pick. Cosine x or 2 cosine x minus 1? What'd you get for answers? Or did you just sit there? You look like I do. Yeah, I can see. Okay, I'll quit picking on you. We'll pick on Cade. What's cosine x equals 0? Yep. Okay. And the other one. Sean, hey, how about that? So you said pi over 3? And 5 pi over 3. Yep. If you want to write those as the degree angle measurements too, you can, to help you relate those. Keeping in mind that you don't get a unit circle on the test. Okay? It's got to be all in the melon. So, all right, any questions? Okay. One more, and we'll be done. Come on. Thank you. All right. This is a tangent secant. So 2 secant squared x minus tangent to the 4th x. Equals -1, I think. Yep. So if we solve this, the book example has the tag for all real values. Okay. When you see that, there's no way in ever that you would write them all down. So we got to come up with an algorithm to represent them all. But your basic answers will show you that. We could change this to sine and cosine, yeah. Might create more of a mess than we want to deal with. Look for identities. Is there one that I can substitute to make them both tan or secant? Like secant squared is 1. Like tan squared x plus 1 or minus 1? Plus 1. Like that? You said plus, right? Is that right? Okay, so I've substituted an identity. Now everything's in tangent. It makes things a lot easier. Okay, so the two big things with solving equations is try to get it all into one if you can, like tangent here, or substituting identities. Okay. Let's distribute. And generally speaking, you're going to want it to equal 0 every time. Yes, it should, because I can multiply. I'm a math teacher. And I like to write these in order. And then bring that across, so plus 3, right, equals 0. And then, so writing them in order and then having a negative on that first term is not friendly for me, so. And that would be, so we're going to change everything by a negative. Okay. Minus 2. Okay. So basically we've manipulated it into a form that's much easier to factor. Okay. This is basically what you're looking at. Okay, can you factor that? It's quadratic form. So we're going to end up with something like this. Okay, so we have an x squared. What do we get for our numbers? Yeah? Good with that? Okay, it's been a few days since we've done it, so I want to make sure. So this is basically what you're doing, but you're doing it with this. Okay. So now it's, yeah, tan squared. That's not right. We're almost done, thankfully, because, okay, minus 3 and tan squared x plus 1. Okay. So these two, basically, you can assist yourself if you want to write it with just x's, that's fine. And it will help you discover the answer here. Okay. So a little strategy. And then you can do the same thing here. Set them each equal to 0. Okay, tan squared minus 3 is 0. That means tangent is root 3, positive or negative. And then, ooh, that looks fun. Plus 1 equals 0, so that means tan is positive or negative root negative 1. Okay, no solutions here, because see this? Do they want complex number solutions? No. Real numbers only, so this here is no solution. Thank you. And where does tan x equal positive or negative root 3? And that's where you have to do that y over x thing. So right. So remember, it's the y's over the x's. So you want a partner of the x is 1/2 and the y is root 3 over 2.
And that was just split each out that part.
Yeah. And you could do any sign combination here too, because it's positive or negative. So we should have 4 answers.
Yeah.
What are they? Pi over 3. 2 pi over 3. Correct me if I'm wrong here. Do you agree?
I agree.
Yeah, okay. Good.
That was my answer. So.
Okay, are these all the real numbers possible? No, it's not. It's only 4 of them. It's 1 revolution, so it represents the only ones we need to really write down. But if you want to represent all real numbers, we have to come up with some sort of a formula to represent it. Okay. So if you look from here to here, what's the difference? So you go from pi over 3 to 4 pi over 3. There's three difference, correct? 3 pi over 3 difference, that's pi. So those two would be written pi over 3 plus pi times any integer whole number. So any multiple of pi. So it would be pi over 3, 4 pi over 3, 7 pi over 3, 10 pi over 3, 13, 16. Get it?
Yeah.
Okay, that's what this formula represents. Those real values for those two. Okay. The other one, it's the same story. You just have 2 pi over 3 as your starting spot. Okay. And we do need to write that k is an integer. Okay. So realizing these functions are periodic and they go on forever, that's what this problem is kind of getting us to see. Okay. You think you can handle some of these? Good? Yeah. Okay, I'll let you work the rest of the hour. I'm going to sit down. Do you want me to write the homework down again?
Sure.
Okay. Canyon.
For these equations to represent the, I can't remember how you said it. Just these equations that you were giving us, Are they always going to be the base value and then
Plus
pi k?
pi k or pi over 2k or 2 pi k, some multiple of pi in order to get your pattern. Yeah. So back to one of the easier ones, 10 through 16, the medium hard ones. Let me know if you have any issues and I will come make you sick. Hopefully not. Okay, me done.